Today we are going to cover the formulae for uncertainty. So right now we are going to cover the formulae for uncertainty. Number one, in case of addition. So for questions involving addition, we'll say that if the values are added, then if the values are added, then values are added, then uncertainties will be added to find the uncertainty of the answer. Let's suppose you have, just for example, you want to calculate a quantity x, which is sum of two quantities a and b. Then the uncertainty in x will be equal to the uncertainty in x will be equal to the uncertainty in a plus uncertainty in b. So whenever two values are added to find a third value, then the uncertainties of those two values are added to find the uncertainty of the answer. So this is the case of addition. Number two, for subtraction. Rule for uncertainty while subtracting the values. You must say that if the values are subtracted, then their uncertainties are still added. So we can say that if you add the values or you subtract the values, in both the cases the uncertainties are added. So whether you add the values or you subtract the values, the uncertainties are added. Now, if x equals a minus b, then the uncertainty in x, delta x, would be written as delta A plus delta B. So if the values are added or subtracted, the uncertainties are yet added. Now, for example, you have a situation in which you have a quantity A that is equal to 10 plus minus 1. You have another quantity B that is equal to 5 plus minus 2. Now, if they ask you find if they ask you to find A plus B, then the answer would be 10 plus 5, that is 15, and the uncertainty in this value would be equal to 1 plus 2. So if the values are added, the uncertainties are added too. Now, if the examiner asks you instead of addition, go with subtraction. Find A minus B. Then the answer would be 10 minus 5 plus minus 1 plus 2. So if the values are added or they are subtracted, the uncertainties are added in any case. Now you can ask the question why. The reason basically is all the formulae for uncertainty that we are discussing, they are based on the concept of random uncertainty. When we calculate the random uncertainty in a measurement by using some readings, then we basically calculate the range of values over 2. So random uncertainty in a measurement is actually, initially we saw how to calculate random uncertainty in a reading. And the method was you used to calculate mean deviation. But right now, if you want to calculate random uncertainty in a measurement, then the method would be you calculate plus minus half of the range of values. So range of values, so range of values over 2. So random uncertainty in a measurement is actually plus minus range of values over 2. And what is range of values? Range is basically the difference between the maximum and the minimum value. So the difference between the maximum and the minimum value is called the range of the data. And range would be equal to maximum minus minimum, and half of this range will be equal to the random uncertainty. Now let's suppose, why are we adding uncertainties while subtracting the values? Let's look into that. Just for example, if examiner asks you, let's suppose x is equal to a minus b. So x is difference of a and b. And what you have to do is that then show that delta x is equal to delta a plus delta b. So basically the simplest form of the formula is that if the values are subtracted, the uncertainties are still added. Now, how will we prove this formula? We'll prove this formula using basic definition. Actually, the uncertainty is half of the range of data. So half of the range of data is basically uncertainty. If we use this concept, then we must say that uncertainty in x will be equal to the maximum value of x minus the minimum value of x. Horrible. So uncertainty in x is equal to the maximum value of x minus the minimum value of x whole over 2. And what would be the maximum value of x? X maximum would be equal to x would be maximum when a is at its maximum value and b is at minimum value. Hence x would be maximum when a is maximum and b is minimum. This would become basically x would be maximum if a is at its maximum value. That is, the uncertainty in a must be added to the value of the a. So this is the maximum possible value that a can have. And minimum value of b would be subtract the uncertainty of b from the value of b. So it will be b minus delta b. Now this is the maximum value of x. If we simplify this, x maximum would be a plus delta a minus b plus delta b. Now this is x maximum. Now you need to calculate the minimum value of x so that you should be able to find the range of x. The minimum value of x would be, as you see, x would be minimum when a is at its minimum and b is at its maximum. This would be x minimum. So x minimum would be equal to the minimum value of a, minus the maximum value of b. For minimum value, you have to subtract the uncertainty. For maximum value, you have to add the uncertainty. So if we simplify this, it would become x minimum is equal to a minus delta a minus b minus delta b. This is x minimum. Now, if we find range of values of x, what would be the range of values of x? Now we should write of values of x. Range of values of x that is equal to the maximum possible x minus the minimum possible x. Maximum value of x is maximum value of x would be a plus delta a minus b plus delta b. We already calculated this. And the minimum value of x would be a minus delta a minus b minus delta b. Now to find the range of values of x, we have to subtract the minimum value from the maximum value, and this subtraction you did that in your 6th or 7th class. So if you subtract two expressions, then you change the signs of the lower expression. So signs of this expression will be changed, as you see. So this a is cancelled with this a, this b is cancelled with this b. Now this would become x ka maximum minus x ka minimum, that is the range of x will be equal to so range of x would be x ka maximum minus x ka minimum, that is equal to 2 times delta a, that is equal to 2 times delta a and plus 2 times delta b. Now you see half of the range is obviously random uncertainty. If we divide both sides by 2, then the left side, as you see, is half of the range of the data, and half of the range of data is actually the random uncertainty. The random uncertainty in x will be equal to if we take 2 common, it would become delta a plus delta b over 2. So this 2 is cancelled with this 2, and as a result, uncertainty in x will become sum of uncertainties of a and b. So uncertainty in x will become equal to sum of uncertainties of a and b. This was the derivation of formula for subtraction. So if the values are added or if they are subtracted, the uncertainties are still added. That is the rule. And the definition of uncertainty is you have to find the range of that for a measurement. You have to find the range of the data, and then if you divide the range of data by 2, then you will get the uncertainty. Now let's go with product and division. Formula for uncertainty while product for product and division. Formula of uncertainty for product and division. So when we multiply two values or we divide two values, how will we calculate their uncertainty? Now, first of all, we should know that for a or a quantity x that is, let's suppose, equal to 10 plus minus 1. This first you need to understand this convention. This 10 is the average of data and this 1 is random uncertainty. And when we state the values, there are no systematic uncertainties because they are already being corrected. Now this is x and this is delta x. One thing, delta x is called absolute uncertainty. That is obviously plus minus 1. So delta x, that is called absolute uncertainty, it is plus minus 1. In the given example, then we have delta x over x. Uncertainty out of 1. That is called fractional uncertainty. That is called fractional uncertainty, and the value would be plus minus 1 over 10. So this is fractional uncertainty. Now if you multiply fractional uncertainty with 100, like delta x over x into 100, then it would become the percentage uncertainty. So you can calculate the absolute uncertainty, the fractional uncertainty, or the percentage uncertainty. So these are the conventions to write uncertainties. However, right now our task is to find the formula for uncertainty in the product of values. So basically, if I ask you, if x is equal to a into b, a and b are the two values which are multiplied to find x. Now, how will you calculate their uncertainty? So to find the uncertainty in x, what we are going to do is that, first of all, we have to calculate the maximum value of x, then we have to calculate the minimum value of x, and then we will calculate the uncertainty. What would be the maximum value of x? You see, the maximum value of x would be x maximum will be equal to a maximum into b maximum. So if we multiply maximum value of a with maximum value of b, we get maximum value of x. So basically, maximum value of x will be equal to maximum value of a. When you add the uncertainty, you will get the maximum value multiplied by maximum value of b. So maximum value of x will be equal to ab plus a delta b plus delta ab plus delta a delta b. So this is the maximum value of x. Now let's write the minimum value of x. The minimum value of x will be the product of minimum value of a and minimum value of b. So this would become the minimum value of x would be equal to the minimum value of a into the minimum value of b. Now if we multiply these two values, then we will get it would become AB minus A delta B minus delta A B and plus delta A delta B. Now you see we have the minimum value and we have the maximum value. The important thing is that how you achieve the minimum value and the maximum value. So when you multiply two values, if you multiply their maximum possible values, then the answer would become the maximum. If you multiply their minimum possible values, the answer would become minimum. So x minimum would be the product of minimum value of A and the minimum value of B. And x maximum will be the product of maximum value of A and the maximum value of B. As a result, if you see, this would become, as you see, the maximum value of x was AB plus A delta B plus delta AB plus delta A delta B. So this is the maximum possible value of x. And the minimum possible value of x is AB minus A delta B minus delta AB plus delta A delta B. Now, if you want to calculate the range of values of x, then you have to subtract the minimum value from the maximum value. And the method to subtract is change the signs of the second expression. A positive sign will become negative, a positive sign will become negative, a negative sign will become positive, a negative sign will become positive, and a positive sign will become negative. Now you see this value is cancelled, this value is cancelled, and the remaining thing is x maximum minus x minimum, basically range of values of x, will be equal to 2 times A delta B, and it would be plus 2 times delta AB. So this is the range of values of x. Since you are subtracting the maximum value of x, you are subtracting the minimum value of x from the maximum value of x. So this is the range of x. Now you see, if you divide the range by 2, you will get the uncertainty. Uncertainty is basically half of the range. So what we did, we divided the range of values by 2, and that would become equal to the uncertainty. So finally what we achieved is, as you see, the maximum value of x minus the minimum value of x, that was equal to 2 times A delta B plus 2 times delta B A, and we divided by 2 on both sides. Now the left hand side will become delta x, uncertainty in x, and the right hand side you can take 2 common, and this would become delta, this would become, in fact I wrote the same thing 2 times. This was basically delta AB. Now you see 2 can be taken common, and it would become delta AB plus delta B A whole divided by 2. Now this 2 will be cancelled with this 2, and the final form of this formula would become delta x is equal to delta a times b plus delta b times a. Now this is not the final formula, because the final formula that we have to prove is in the form of fractional uncertainties. In case of product and division, we go with fractional uncertainties and not with absolute uncertainties. One last step is that if you divide the whole equation, if every term in the equation is divided by, if you want to go with fractional uncertainties, then you divide every term in the equation by x. And you already know that x is the product of a and b. X is the product of a and b, so it would become the fractional uncertainty in x is equal to delta a into b over ab plus delta b into a over ab. Now you see this b will be cancelled with this b, this a will be cancelled with this a, and the final formula would become delta x over x is equal to delta a over a plus delta b over b. Now if we read this formula in the simplest form, that is, if two values are multiplied, then fractional uncertainties of those two values are added to find the fractional uncertainty of the answer. So if you multiply a and b, you'll get x. However, if you add fractional uncertainty of a and fractional uncertainty of b, then you'll get the fractional uncertainty of the answer. So we need to write this in words. Basically, what we have proved is that if two values are multiplied, then their fractional uncertainties are added. So if two values are multiplied, then their fractional uncertainties are added to to find the fractional uncertainty of the answer. Basically, if x is equal to a into b, then fractional uncertainty of x will be equal to the fractional uncertainty of a and the fractional uncertainty of b. So basically, if x is multiple of a and b, then fractional uncertainty of x will be equal to the fractional uncertainty of a and the fractional uncertainty of b, their sum. So sum of fractional uncertainties of a and b will be the fractional uncertainty of x. This is when the two values are multiplied. Now, what about the division? For division and power, the way I prove formulae for subtraction and product, I will like you to prove the formula for division and power. You have to show that if x is equal to a over b, then you have to show that then basically then show that delta x over x is equal to delta a over a plus delta b over b. This is what you have to prove. So if you divide a over b and you get a value x, then by adding their fractional uncertainties, you will get the fractional uncertainty of the answer. So this is what you have to prove yourself. And one other proof that basically you can say that it's your homework. One other question that you have to do is that if x is equal to a power n, then show that delta x over x is equal to n times delta a over a. So basically you have to prove that the power becomes the coefficient. You have to prove that the power becomes coefficient when you write the formula for uncertainty. Now today the homework for you is that you have to prove two things. First of all is, if two values are divided, then their fractional uncertainties are added to find the fractional uncertainty of the answer. This is one thing. And the second thing that you have to prove is that the power in a formula will become coefficient. So today we have to do up till this point, and we are almost done with the chapter. Now only examples are remaining, and from tomorrow we will do examples and past paper questions. Khuda Hafiz, students. Take care.